Hi, this is Franklin Yamamoto with SQLGrease. Today, I will be demonstrating how SQLGrease can be used to find and tune your most impactful queries. We'll start by logging in and going to the history view. By default, the history view shows the last day of activity. These stat columns represent total elapsed time of queries executed. Each stacking represents a different query. This makes it easy to identify which queries are contributing to the most activity in SQL Server. Below the chart, we have a summary of all query activity for the selected time frame. The top row is the query contributing to the most activity. We can click the details link in the summary, or we can click on the query in the chart to view the query details. At the top of the query details view, we see what wait events contribute to the elapsed time of the query. A majority of the wait is spent lock contention and CPU time. From looking at the query stats, there are a couple of indicators of a potential problem. Average rows affected per execution is 0. Logical IOs is 682. That is a lot of logical IO for not updating any rows. Looking at the query, it appears to be updating the customer test table by the account number. This should be a selective enough value that an index should get used. Let's look at the execution plan next. This sounds like the problem might be plan related. It appears there is a plan warning for the execution plan. The plan warning is for an implicit conversion. I'll include a link to a blog post I recently wrote in the video description. This post describes what an implicit conversion is and how to fix it. Let's download the plan and see what it shows. As the warning indicated, there is an implicit conversion and it appears to be generating an index scan. We'll fix the implicit conversion and see what kind of difference it makes. Now that we fix our problem, we'll get logged back in and go to the history view. Let's shift our time frame to the last 2 hours. It appears there was a noticeable drop in activity. We'll go to the query details view next. Notice our wait events change. We now have less lock wait in CPU, but now have write log wait. Write log wait is generally the result of committing writes. Notice the reduction in logical reads and elapsed time. These values are for a time frame that includes executions while we still had implicit conversions. To see the true impact of our change, let's take a look at the average response time of the query over time. In this chart, we see our average execution time, number of executions, and CPU time. Our average execution time dropped significantly. As a result, the execution count showed an increase. Prior to our change, our average execution time was about 1 second with 112 executions per minute. After our change, our average execution time dropped to 0.002 seconds with 5,256 executions per minute. Our change made a significant enough increase in throughput that we moved our performance bottleneck to a new area, which is transaction log throughput. This would explain the write log wait. As a last check, let's review the execution plan. We now have 2 execution plans. The new plan does not have a warning. Let's download the plan to see what's happening. you can see the new plan is now performing an index seek. Thank you for watching.